In this example, we're going to multiply two rational expressions. When we're multiplying rational expressions, our first goal is to fully factor all of our numerators and denominators. The reason for fully factoring is we might be able to cancel off some common factors in our numerators and denominators. So let's go ahead and start factoring. The numerator of our first fraction factors into x minus 3, x plus 2. The denominator of our first fraction, we can pull out a common factor of x, and that's going to leave us with x plus 2. For our second rational expression, our numerator, we can factor out a common factor of x squared, and that leaves us with x plus 1. And then our denominator, we can factor this trinomial into x minus 3 times x plus 1. Now that we have everything fully factored, we can check to see if there are any terms in the numerator that are going to cancel off with terms in the denominator. For example, I see an x minus 3 in the numerator here and an x minus 3 in the denominator here. So we can cancel these off and we're left with factors of 1. Similarly, we can cancel off our x plus 2's as well as our x plus 1's. This leaves us with x squared in the numerator and a single x in the denominator. And we can use our power laws here to simplify. And our final answer is given as x. Let's work through one more multiplication question. Let's begin by trying to factor every single polynomial in our numerator and denominator. We begin up here. We have a difference of cubes, x cubed minus 27. Using our difference of cubes formula, this is going to factor into x minus 3 times x squared plus 3x plus 9. In the denominator of our first rational expression, we have a difference of squares, and this will factor into the conjugate pairs x minus 3, x plus 3. In the numerator of our second rational expression, we have another difference of squares, 4x squared minus 1. This is going to factor into 2x minus 1 times 2x plus 1. And in the denominator, we have a trinomial. And when you factor this trinomial, you should end up with the factors 2x plus 3 and 2x plus 1. So now that we have everything fully factored, remember that this quadratic is not going to factor. We can begin canceling off any common factors in our numerator and denominator. I notice that there is an x minus 3 factor over here that we can cancel, noting the restriction. And we have another cancellation of 2x plus 1. So this is going to give us a final answer of x squared plus 3x plus 9 times 2x minus 1 all over x plus 3, 2x plus 3.